welcome back. So let's start talking about terminology. As you study your law degree, you'll find that you will get more and more focused on individual words and their meaning. And even though here we're not necessarily talking about legal terms, we're talking about terms that relate to technology and terms that relate to the business or the profession of lawyering. It's going to be really important that you really take care to adopt the terms that have precise and concise meanings. That it's going to be very important, particularly in your first assignment where you have only a very small number of words to work with, that you are using the terminology correctly and appropriately to convey the appropriate meaning to your audience. So let's start by, I'm actually going to start by talking about artificial intelligence in particular. And there are many different kind of things that we think about when we think about AI. In fact, Professor Toby Walsh from ANU, I think, he's also part of CSIRO's Data 61 project, and a really well-acknowledged academic in the field of artificial intelligence. In fact, actually, here's his book, which I'm likely to refer to as we talk about this, called Machines Behaving Badly. And it's literally a book in very readable terms entirely on the question of whether artificial intelligence should have some kind of ethical code associated with it. And why did I start talking about Professor Walsh? Because I think as we think about the kind of language that we use, I mean, he, somewhat jokingly, maybe not, refers to AI not just as artificial intelligence, but as alien intelligence. Let me explain. One of the conundrums that you're going to keep coming across as you do the reading for this particular subject, and as you start thinking and preparing for the tutorial, is that you're going to start thinking about how artificial intelligence is the same as or different from intelligence. Human intelligence. Now, some of you might have already been exposed to the idea that there are many different forms of intelligence. Often we think about intelligence as meaning something like IQ, so an intelligence quotient, this idea of something that you can measure about how analytical or how smart you are. But those of you who are aware of that, and maybe you had IQ tests at school at some point along the way, the NAPLAN test, a form of IQ test, you were probably assured that actually there's many more types of intelligence than just academic intelligence, or the sort of intelligence, the logic and reasoning type intelligence that is measured by those kind of tests. We also have emotional intelligence. Emotional intelligence is a relatively new field of science, but it's really around looking at how we can recognize and regulate our own emotions and how we recognize and respond to the emotions of others. Some people have strong kinetic intelligence. I am not one of those people. So hand-eye ball coordination, those kind of things. There are many different forms of intelligence, but all of those kind of intelligence that I'm talking about, the thing they have in common is they're forms of human intelligence. And so when we're talking about artificial intelligence, or as Professor Walsh jokingly calls it, alien intelligence, we're trying simultaneously to do two things. One, to understand what's similar around the kinds of intelligence that machines carry with them or can deploy, and what's similar to machine intelligence and human intelligence, but also where they are different. The words artificial intelligence sometimes feel unnecessary. Isn't intelligence just intelligence? And I think when we think about it, a good analogy might be to use the words artificial flight. Before the Wright brothers flew their bicycle with wings off the edge of a cliff somewhere, I'm not sure that they flew it off the edge of a cliff, but bear with me for the analogy, we might have called what they were trying to do artificial flight, because we're comparing it, say, with the way that birds fly. Now, we all know now, as we sit in an aeroplane, that we are flying, but we know that that is something different from what we say or mean when we say a bird is flying. If we as humans tried to fly the same way that birds fly, we'd be flapping our wings and not going anywhere, right? So flight, artificial flight, involves some sort of engine, some sort of aerodynamics, some sort of physics that's well beyond my pay grade. But at the end of the day, it's still flight. But it is very, very different from natural flight. Artificial intelligence may well still be intelligence, but how and why is it different from human intelligence? Now, there are some things that we know for sure. So we associate the idea of intelligence or natural intelligence with life. We might say we have an intelligent dog or an intelligent cat, but we know that that is something quite different from the intelligence that we carry with us as humans. Yet at the same time, they have great similarities. There's problem solving. It's something that is biological, and by biological, it's associated with life. But when we're talking about machine intelligence, robots, and by robots here, I don't necessarily mean the clunky old robot kind of idea from science fiction, danger, Will Robinson, danger, Will Robinson. I'm really talking about robots in the sense of something that uses programmable intelligence, programmable like code, to function. Now, we know now more and more robots actually have no physical form. The robots that we deal with on a day-to-day basis might include Siri on our phone. I have to be careful when I say that. I have an iPhone. Sometimes it talks to me while I'm talking. Maybe it's a chatbot that you use when you're talking, say, to the tax office. The tax office uses a chatbot called Alex, which saves people hundreds of hours of time when they try to get information about a complex system, complex piece of legislation and regulation that otherwise they might spend hours trawling a website to get to. And we call these bots or robots because essentially based on some kind of code, they respond to us in an intelligent fashion. So when we're talking about artificial intelligence generally, and when we talk about it in this course, we're going to be talking about a constellation of many different types of technologies. Some of them will be code, some of them will involve machine learning, some of them might be physical things, like the robot arms that assemble machines or autonomous vehicles. We might be talking about production lines. We could be talking about a whole range of different physical and coded technologies that work together to enable machines to sense, comprehend, act, and learn. And at the end of the day, intelligence is about sensing, comprehending, acting, and learning. Machine learning. So machine learning is generally a subset of that broader idea of artificial intelligence that refers to programs that can learn from past data, so the results that they see, to make better decisions in the future. Now, you're not a machine, but since the minute you were born, you have essentially been using data inputs to learn. Sometimes you do that very consciously. Remember when you slaved over repeating those times tables so that you could do them like this, or maybe like that. Like me, you never actually got there. And sometimes you do it without even noticing. So right now, you probably don't think about it when you pick up a pen and start to write or start to type something on a keyboard. But there was a point in time where even holding the pen or a pair of scissors was quite difficult for you because you hadn't done it before, and it was a whole new set of motor skills that you weren't born with them. You develop them over time. One of the things that's really interesting about machine learning is that once one machine has learnt something, whether that's at the dumb end of just retaining data or whether it's actually doing something with the data, there is no lag time for the next machine. Now, when we think about the history of humanity, we have, over time, we can see this evolution, that tools were developed and used, and it took a lot less time for the next generation to get moving. Sort of each generation kind of takes on the technologies and the learnings of the generation before and moves forward. But it does so on a generational scale. Computers can do that on an immediate scale. So data that can be transferred from one machine to another, it's almost instantaneous. Where data that goes from my brain to yours, maybe not so fast. You tell me. So machine learning is really about this action of a program using data inputs to learn something. Now, some pretty interesting things that come out of that kind of technology. In particular, we don't know why or how machines learn the way that they do. So you'll come across this language quite regularly about black box technologies. We have this issue where we don't really know why machines reach the conclusions that they do. When we think about it, we don't always know why humans reach the conclusions that they do either. There can be real difficulties in pulling apart what is logical and reasoned and to what extent we carry around with us unconscious biases, things that we believe to be true because they haven't been proven otherwise to us, or things that we know about our society or our culture that we don't question. I think of this as the Copernicus factor. Copernicus, look him up if you haven't heard of him, but he was very concerned about how the mathematical model that was around of the universe at the time that he was gazing into the night sky, it never really totally made sense. The maths was never completely right. And he came close to being burned at the stake as a heretic because he was the one who stopped and said, well, what if the sun doesn't travel around the earth, but in fact the earth travels around the sun? The maths would work differently there. Now, that required a total rethinking of the understanding of the universe at the time. Now, I know we remember this as, Copernicus, having this problem with the Catholic Church and the Church being ready to call him a heretic. But nobody ever really thinks, and I know you don't think either, that those people who believed that the earth was traveling, the sun was traveling around the earth, that they were stupid people. Nor were the people many years before, or not that many years before that, who thought the earth was flat. We didn't think they were stupid people. They just hadn't seen that world. They hadn't posited a hypothesis yet that would see the world differently. And so in the black box that was Copernicus' mind at the time, he was able to see the world differently and think about the world in a different way and propose a different way of viewing things. Now we see the world in the way that Copernicus did, but many people didn't at the time, and articulating that logic, that internal logic, was not an easy thing. Again, I think we can get lost in this definition of this difference between machine learning and the way that humans learn. But I do think that we do need to stop and think about, well, what don't we know about the assumptions that get carried with these things? Back in the late 90s, early noughties, I did a lot of work for a startup technology company that did some really excellent work in facial recognition. And one time they had a launch and they're basically showing off their tech and it's working absolutely brilliantly. It was very clever. It could tell the difference between a photograph of a person and an actual 3D person. And yet somehow it could never find me. Just never found me at all. And it was only probably 10 years later that I realised, because I'm interested in this field and I'm reading a lot about it, that the reason for that is the machine or the software was trained using photographs and using images of the people who programmed it. And they were essentially middle-aged white men. And at the time, this is a while ago, I was a woman in her 30s. I was a fair complexion. I wasn't the same as the people who were coding. And so the machine itself had developed an unconscious bias that every time it had been told, yes, you got that right, that was a real human as opposed to a picture, the real human was a middle-aged white man. And so, okay, that's a fairly simple thing for us to discover over time as to where that bias comes from. But if that simple bias is there, what other biases come both from the people who train the machine intelligence or the machine learning, or from the people who code the machines in the first place? Something we constantly need to think about. The other two terms in relation to AI that I want to spend a little bit of time on is narrow or weak AI as opposed to general or strong AI. Now, what is really kind of interesting here is that we are mostly these days dealing with narrow AI, though you will find that much of the reading and the thinking that's being done, particularly in the legal profession, seems to focus on general or strong AI, even though we're probably not there yet. So weak AI is really about finding systems that operate in a narrow playing field to drive efficiencies for the most part, but they tend to be very focused on the one thing that they can do, often decision trees or recognizing particular issues or questions in a particular context. The general or the strong AI is the kind of thing that we recognise from movies, television, popular culture. The idea of a sentient machine that can emulate human intelligence, that it thinks maybe strategically or abstractly or even creatively. Many would argue that we're a long way from real, true, strong AI, but there are certainly many narrow or weak forms of AI that I would describe as being very strong. And so maybe it's better to think about AI in the way that's sitting out on this slide, where we can think about it as being reactive, sort of early stage AI, the sorts of things that we deal with quite regularly, like so chatbots, for example, or predictive text. It reacts to what it sees in front of it, matches it with something else. So one of the first forms of kind of reactive, limited, narrow AI that many of us deal with would be the little squiggly lines underneath a word that we've misspelled using Microsoft Word. So that is a limited form of AI. One of the things that's really interesting is when something becomes ubiquitous, we tend not to think of it as AI. We focus our attention on the general AI, which is much, much harder to anticipate. Of course, there's also AI that has the limited memory type. So really focused on a particular application. So limited memory AI can handle complex classification tasks. It's able to use historical data to make predictions. It's capable of complex tasks, including, so for example, self-driving automobiles, but it is really vulnerable to outliers or adversarial examples. So one of the things that is really going to slow down the introduction of full AI autonomous vehicles in Australia is, of all things, the kangaroo. Kangaroos are really, really unpredictable. And to get AI to respond to this animal that bounces all over the place can be really quite difficult. But limited memory AI is probably the best type of AI, the closest we have to strong or general AI these days. Other examples of limited memory AI might be the predictive analysis diagnostic tools that are being used in medicine. And both of those videos that are on Canvas really focus in on that type of AI. What are we looking for next? So a theory of mind AI moving more towards general or a strong AI. So this is where machines would be able to understand human motives and reasoning, intelligent, emotionally intelligent, sentient machines, or maybe not sentient, but at least emotionally intelligent. We're seeing some signs of that. There is AI that's been able to recognize the difference between a fake and a forced smile, and to recognize from tone of voice. So much is happening in the voice space at the moment. What somebody's emotional state is. It's also able to predict what kind of voice that a person in an emotional state might respond positively to. A theory of mind AI might be able to learn with fewer examples because it can think about motive and intent. And again, it's considered to be the next milestone for the evolution of AI as we know it. And really ultimately moving towards this general AI is that self-awareness or sentience. I'm not sure that I can answer with any kind of accuracy whether general AI is even possible. I think what I put on the slide here is a really useful way of thinking about the differences between general and narrow AI, and I really think there is value in you thinking about those differences. And when you're writing about any kind of AI application in the legal profession, make sure that you're using the terminology as clearly and as efficiently as possible. Let's move on to the other terms that you're going to be reading about in this material. And we've got some theory here, so some language that's really important about disruption. So now disruption, I think we feel like disruption is a term that we understand. When we hear about something being disruptive, I don't know, I immediately go to the naughty boys who were disruptive in the classroom when I was in high school, maybe because, or in primary school, maybe because I've worked in a startup, and startup land is full of noisy boys who make a lot of noise and they really call a lot of attention to themselves. But actually, in a technical sense, the term disruption was coined by an academic out of Harvard University called Clayton Christensen. He really looked initially at the ways in which startups can come up and surprise incumbents. So when we're looking at different types of technology, we can think about them this way. And in the legal profession, we're talking significantly about sustaining technologies and disruptive technology. And so what do we mean when we're talking about disruption? I'm going to draw a picture for you, I think. So just give me a second. Okay, now, so bear with me while I try and draw a picture. My drawing is terrible, by the way. If you're listening to this on the podcast, make sure that you have a look at the slide, maybe have it in front of you with whatever my end drawing is, to see if you can make sense of it. So as an example, I'm going to use a technology that I think you're probably aware of. But before we start, let's think about it. So we're going to use two axes. On here, on my x-axis here, this is t for time, and on this side I've got p for performance. So how long does it take to do something here, and what is the status of performance? So let's use as our example something that I'm sure you're familiar with, this idea of the camera, and we used to use this wonderful stuff called film. That, believe it or not, is supposed to be some film, just to remind you. And there was a company that I'm sure you might have heard of, Kodak. So Kodak made film. Actually, I don't think it had a C in its name. Sorry, terrible me to do that. So it made film, and back when it first started making film, it didn't do a particularly good job of it, but over time it got better and better at making film. Now, at some point along the way, let's actually first, before we think about people, before we think about the competitors, before we think about the competitors, let's think about the users of film. So these are people who have cameras. That's supposed to be a camera. And initially, or maybe they just want pictures of people that they love. That's what they're looking for. So these are our users. When the camera was first invented, in fact, really it was very expensive technology. It didn't do very much, and very few people actually used it. But over time, so let's call that the expectations of the user, and over time the expectations of the user got higher. Kodak was actually at its height in the 1990s, was a massive company. Its technology was better than any of its competitors, was used by all the best photographers and filmmakers worldwide, but it also was used by mums and dads and people who had home and Instamatic cameras as well. It printed pictures, it created film, and film was really its absolute most exciting thing that it did, the thing that it really felt that it was good at. And at some point, actually during the late 80s, early 90s, it actually invested in some R&D to create what we now would think of as a technology to deal with digital photos. And so digital cameras were actually patented by Kodak at one stage, but at the end of the day, so let's say it starts about here. I'm using rainbow unicorn blood color for this disruptive technology. And what it was at some point, it was really, even though it was growing, it was well and truly under the expectations of the users. And Kodak on this, Kodak is basically thinking, well, why would we bother with this technology? It's sitting there, it's not as good as what we do, it's completely different from what we do, it takes our eyes off the main game, and it's going to be delivered in a completely different way. People are going to have to buy different cameras, everybody's already got a camera. So Kodak at this stage is the incumbent technology. But as these technologies got better, they probably started a little bit further down than that, as those technologies got better, more and more of these people focused on what they wanted, which in fact was less likely to be the actual high-tech end film. That's not what they wanted. What they actually wanted was a picture of the person that they love. And as it turned out, as soon as you could put that on a phone, as far as this person's concerned, their expectations are met. And so pretty much out of nowhere, this incumbent technology, which was cheap and cheerful, basically killed the incumbent technology. So this is what we mean when we talk about disruption. It's coming up from underneath in an unexpected way. So we could think about this in a sense of lots of other types of technology as well. So if we weren't thinking about Kodak, for example, we might think about the typewriter, the humble typewriter, being taken over time by the personal computer. That initially word processing or computers were not nearly as interesting or as useful to our end users who are getting mauled there by rainbow blood, unicorn blood. Instead, they were really it was just a newfangled technology. It was seen as being geeky, it wasn't really for lawyers to use. But now we've seen a significant change in relation to that. So here is a prettier picture, or a little clearer picture. It's really just showing how, in fact, actually, what was a sustaining innovation, what was a disruptive innovation over time may well become, like the digital camera, the ubiquitous or the sustaining innovation, and a new disruptive innovation can come up underneath. So when we talk about disruption in this course, in this sense, we're usually talking about Clayton Christensen's oh goodness me, a definition of disruption, and I think that that is really important to remember. So returning now to sort of the broader model, I hope it's a little bit clearer what we mean when we're talking about disruptive technologies. Sustaining or incumbent technologies are technologies where there is a significant improvement on a product which aims to sustain its position in an existing market, but the technology itself is rarely new, and it usually has significant impact. So some of the sustaining technologies that it might surprise you are being used by lawyers every day are things like Microsoft Word, Outlook, the email program. One of the things I find almost amusing is that in law firms we have a significant expectation that everybody knows how to use email and use it really effectively, finding things, filing things, using it quickly, using templates and quick parts and things like that, because it's been the bread and butter of every lawyer for the last 20 years or so, and we kind of forget that young people don't use email anymore. And my guess is that there will be some kind of disruptive technology that replaces email over time. That might be something like Slack or Teams, because of that ability to have one conversation in one place. But it'll be really interesting to see. I don't want to discount the importance of incremental technologies either, those gradual continuous improvements that we hardly even notice. Now, it's fun and interesting to talk about the radical technologies, those breakthroughs that transform the market, but it is very rare that they become ubiquitous. And but again, I've always been interested in technology, so I'm checking everything out. And who knows which ones are going to be the really important ones over time. I like to think about this question this way, thinking about disruptive innovation as being looking for the things that currently only have a small market, they tend to have low margins, the risk is significant, and there's a huge growth potential if everything goes well. A really good example of that could be Zoom. They've been using video conference for a long time, but some people were using Skype, but it had some bug issues, and it wasn't, even though people used the name Skype, it wasn't really associated with any particular video conferencing technology. Zoom, I've been using it for a number of years actually, and it's pretty easy to use, and it's what we would call device agnostic. It didn't sort of really care what kind of machine you were using it from, whether that was a phone or a PC or a Mac or anything else. And it was very low cost, very easy to install. You could just use it on the web if you needed to. And when the pandemic began and people had to transition to working online very, very quickly, Zoom really zoomed into the stratosphere, and really it did so very quickly. It had a few privacy and bug issues at the beginning, but it really made a significant difference, and the potential for that company is really significant now. Sustaining innovations, on the other hand, have large markets. They tend to have high margins, they're lower risk, and they have some growth potential, but really once they get to the point where their features and functionality far surpasses the needs or expectations of their users, really they're in a defensive mode. Okay, so they're the terminologies that I really wanted to focus on. In the next video, I'm going to try and look into the future.